Hello, friend. Welcome to Science for Sleep. Whether you have returned tonight or are discovering this channel for the first time, this is a quiet place to slow down, learn something gentle, and allow the day to gradually fall away. A pet cat waits beside a door, slips through a cat flap, crosses a porch, or passes beneath a garden fence. Within seconds, it has disappeared from view. It may seem to have entered an open world with no clear path, but tracking studies show something different. Outdoor cats move through structured areas filled with repeated routes, stopping places and boundaries invisible to people nearby. The animal at the center of this journey is an owned companion cat that receives food, shelter, and care from people, but is allowed to roam outside without direct supervision. This is different from an indoor-only cat, a harness-walked cat, a lost stray, or a feral cat living mostly apart from people. Those cats may cross the same patch of grass, but their daily lives can be very different. If you enjoy these quiet journeys, you're welcome to subscribe. And if it feels natural, to leave a comment sharing where you're listening from tonight. It helps others find this calm corner of science, one sleepy listener at a time. For most of history, people could only guess where a cat went after it vanished beyond the house. Someone might see it again on a wall beneath a parked car, or at the edge of another garden. Everything between those sightings remained hidden. That changed when satellite tracking devices became small and light enough for cats to carry. A global positioning system device, or GPS tracker, records estimates of the animal's location at set times. Each reading creates a dot on a map. One dot may appear beside the house, another behind a shed, and another along a fence several minutes later. When hundreds or thousands of dots are collected, they reveal the shape of the cat's outdoor life. In 2020, one of the largest projects of this kind followed 925 pet cats from 6 countries. Most came from Australia, New Zealand, the United States, and the United Kingdom, with others in Canada and Denmark. Most wore a small GPS unit for several days while continuing their normal routines. The combined maps produced an unexpected result. Most cats did not travel across enormous areas. Their average home range was about 3.6 hectares. A hectare is a square measuring 100 meters on each side, so 3.6 hectares is roughly the area of 5 standard soccer fields. A home range is the full area an animal regularly uses for traveling, resting, feeding, hunting, and other ordinary activities. It is not necessarily a space defended against every other cat. Only 3 of the 925 cats used ranges larger than 1 square kilometre. One British cat travelled about 1.7 kilometres along a road between 2 villages. 2 New Zealand cats also produced unusually large maps, one through farm fields and another through natural areas. These journeys mattered, but they were not typical. For most cats, the hidden world remained close to home, often within roughly 100 meters of the place where the journey began. That distance can include several gardens, a row of houses, a small field, or a maze of sheds, fences, trees, and narrow passages. It may contain places where a cat rests in sunlight, waits beneath cover, watches birds, meets another cat, or investigates a scent left hours earlier. The small size of the map does not mean the cat is inactive. An animal can walk back and forth through the same compact area many times, building a long journey from short repeated paths. It can circle a building, retrace a fence, return to the garden, and leave again without traveling far in a straight line. The doorway remains the fixed center of this movement. Food, warmth, familiar people, and secure resting places draw the cat home, while sound, scent, movement, and changing conditions pull it outward. The first surprise of outdoor life is not how completely the cat escapes the human world. It is how much can happen within the first small ring of land surrounding the house. That ring begins with the first 50 meters beyond the door. Just beyond the property line, the cat enters an area that researchers call its home range. A home range is the full stretch of land an animal regularly uses during ordinary life. It can include feeding places, resting spots, travel routes, hunting grounds, and areas used to find a mate. The boundary does not need to form a neat circle. A hedge may push the route in one direction, while a road or tall fence may limit movement somewhere else. The shape often follows buildings, gardens, fields, and narrow passages between them. A home range also differs from a defended territory. Several cats may use the same garden, lane, or patch of grass during different parts of the day. The mapped area shows where the cat travels. It does not automatically show that the cat owns every part of it or drives every neighbor away. Within the full home range lies a smaller area that receives much heavier use. Researchers often call this the core area. GPS points gather closely there because the cat returns again and again. A favorite shed roof may sit inside the core. So might a sunny wall, a sheltered hedge, or a place where small animals regularly move through vegetation. A rare trip across a road can stretch the outer home range far from the house. The core area gives a clearer picture of where most outdoor time is actually spent. This difference appeared clearly when researchers followed 92 owned cats in a residential area of southern Norway. Each cat carried a GPS tracker for an average of 21.4 days. That was long enough to record regular routines as well as some less common excursions. The researchers calculated an average home range of 2.6 hectares. 1 hectare covers 10,000 square meters, equal to a square measuring 100 meters on each side. The average core area was only 0.2 hectares. That smaller space covered about 2,000 square meters, roughly the size of several neighboring gardens placed together. It was close to 1/14 of the wider home range. The outer map showed everywhere the average cat was likely to travel. The dense inner map showed where much of its outdoor life was concentrated. Male cats in the Norwegian study used average ranges of 3.7 hectares. Female cats averaged 1.5 hectares. These figures describe a pattern across the group rather than a rule for every individual. Some females traveled farther than nearby males. Age, local barriers, outdoor experience, and the arrangement of nearby homes could all alter the final shape. The most memorable result involved distance from the owners' houses. On average, the cats spent 79% of their recorded outdoor time within 50 meters of home. 50 meters is shorter than the length of many city blocks. In a residential neighbourhood, it might reach across a road, through 2 or 3 gardens, or to the far side of a small park. The average outdoor GPS position was 58 meters from the house. A cat could therefore remain unseen for hours, while spending most of that time remarkably close to the people waiting for it. Some individuals still made much longer trips. A single distant excursion could extend the edge of the map, even when the cat rarely returned to that place. This is why the core area and full home range need to be measured separately. They describe different parts of the same outdoor routine. A compact range also allows a cat to travel a surprising distance. Distance traveled measures the complete length of the route. Home range size measures the amount of ground containing that route. A cat can cross one garden, follow a fence, turn behind a garage, and return along the same path. Later, it may repeat part of the loop before visiting a nearby shed. Each movement adds to the daily distance, while the total area remains almost unchanged. Several kilometers of walking can fit inside a small neighborhood when the path bends, overlaps, and doubles back. The cat may patrol the same boundary many times because the information there keeps changing. A new scent may appear on a post. Birds may begin feeding beneath a tree. Another cat may have passed through since the previous visit. The small scale makes these changes easier to inspect repeatedly. The hidden life outside the home is therefore concentrated rather than empty. A few surrounding gardens can contain resting places, social boundaries, prey routes, and safe passages known in fine detail. Even a circle extending only 50 meters from the house can hold hundreds of possible paths. To understand which paths the cat truly follows, scattered GPS dots must be turned into a continuous map. The boundary drawn around a cat's outdoor life begins as a collection of separate location readings. A GPS unit receives signals from satellites orbiting thousands of kilometers above Earth. From those signals, it estimates the cat's latitude, longitude, and the exact time of the reading. The result is a single dot placed somewhere near a house, fence, garden, or road. Another dot may appear several minutes later. Some trackers record a position every few seconds, creating a detailed trail while using battery power quickly. Longer gaps allow the device to operate for more days, though brief movements between readings may disappear. Each dot confirms that the cat was probably near one location at one moment. It cannot show whether the animal was sleeping beneath a hedge, watching a bird, or simply passing through. Earlier tracking studies often used radio telemetry. A cat wore a small transmitter that produced a radio signal. A researcher traveled through the area with a directional receiver and listened for the signal from different positions. By comparing its strength and direction, the researcher estimated where the animal was located. This method could follow cats before modern GPS collars became practical. But collecting each reading required time in the field. A researcher might record only a few positions during one day. GPS devices can gather hundreds of readings while the cat continues its normal routine without anyone walking behind it. Greater detail brings new problems. Satellite signals may weaken beside tall buildings or beneath thick tree cover. A cat entering its home can produce a cluster of inaccurate points around the walls. Batteries eventually run down, collars can fall off, and some cats refuse to wear unfamiliar equipment. Device weight also matters, because a tracker that seems small to a person may feel much larger on an animal weighing 4 kilograms. Researchers must turn the usable readings into a shape that represents the cat's range. One common method is called a minimum convex polygon. Imagine placing an elastic band around the outermost GPS dots. When released, the band forms the smallest shape that contains them. This gives a simple estimate of the total area reached by the cat. A single distant excursion can stretch the polygon far beyond the places used during an ordinary day. Another method creates a kernel density estimate. This produces something similar to a heat map. Areas containing many GPS readings appear more heavily used, while places visited only once remain faint. The map can reveal a compact core around several gardens, even when one long trip extends the outer boundary. A Brownian bridge movement model adds another layer. It considers where the cat was recorded, how much time passed, and how far apart two readings were. From that information, it estimates the likely corridor traveled between them. A point behind one house followed 2 minutes later, by a point beside the next garden suggests a narrower path than two locations recorded several hours apart. A study in southwestern Ontario used several of these tools to examine cats around Kitchener, Waterloo, Cambridge, and Guelph. Each participating cat wore a breakaway collar designed to open if it became caught. The collar carried a GPS unit weighing 35 grams, along with a small camera that could record part of the animal's outdoor behaviour. Owners were asked to gather at least 20 days of activity during a 5-week period. After inaccurate and unusable readings were removed, the researchers retained 41,092 GPS positions. Those thousands of points still represented samples rather than every movement. A cat could climb a fence, pause beneath a car, and cross a driveway between two recorded locations. Tracking duration also changes the final map. 7 days may capture the normal routine while missing a distant excursion that happens once each month. Several weeks provide more chances to detect unusual travel, though batteries, weather, and lost collars make longer studies harder to complete. The chosen mapping method changes what becomes most visible. A polygon emphasizes the outer limits. A heat map shows the places receiving the greatest use. A movement model estimates how the cat probably traveled between its recorded positions. Each approach measures the same outdoor life from a different angle. The finished range is therefore a careful statistical estimate, built from incomplete observations. It cannot reproduce every paw step, yet it reveals patterns that occasional sightings could never show. Once the dots are joined, they begin gathering along particular fences, buildings, edges, and sheltered stopping places. The connected track begins to bend around the structures closest to home. It follows the side of a house where the wall blocks wind and creates a narrow strip of shelter. A few meters later, the line slips beneath a hedge, passes behind a shed, and continues along the base of a wooden fence. The cat may squeeze through a gap between two gardens before pausing beneath a parked vehicle. These movements give the map an uneven shape. Large patches of open ground may contain very few GPS readings, while a narrow boundary receives repeated visits. The cat is linking useful features across the neighbourhood. A hedge offers cover while allowing sounds and scents to pass through. The wall of a building can guide movement while protecting one side of the body. A shed creates shaded resting space, an elevated roof, and small gaps where mice or insects may appear. Fences can perform several roles during the same journey. The base may form a sheltered travel lane. The top can provide a raised walkway with a clear view into nearby gardens. Posts and corners also create firm surfaces where cats may scratch, rub, or investigate scents left by other animals. Edges often attract movement because they connect open and covered space. A cat beside a hedge can watch a lawn while remaining partly concealed. A route along a wall limits the directions from which another animal can approach. Vegetation beside a driveway may provide quick cover if a person, dog, or unfamiliar cat appears. These advantages help explain why two areas of equal size may receive very different levels of use. Researchers study this pattern through habitat selection. They first record the places an animal uses. They then compare those locations with the types of land available nearby. A cat might spend many hours around houses simply because houses cover most of its neighbourhood. Selection becomes clearer when a feature receives more use than its local availability would predict. This approach was applied to cats living around Kitchener, Waterloo, Cambridge, and Guelph in southwestern Ontario. Their average minimum convex polygon range covered about 8 hectares. Individual ranges varied from roughly 0.34 hectares to almost 38 hectares. The GPS locations were divided among several broad land types. 73% fell on surfaces classed as impervious. 22% occurred on mapped roads. Only 4% were recorded in green spaces. The word impervious refers to surfaces that water cannot easily soak through. In this study, the category included developed residential, commercial, industrial, and civic areas outside the separate road and green space classes. The result reflects an entire human-built network rather than a simple attraction to pavement. Houses, decks, sheds, parking areas, alleys, and fenced yards can all provide routes or stopping places. Food may also be available around homes through pet bowls, compost, garbage, bird feeders, and rodents living near buildings. Artificial structures can hold warmth after sunset and create dry shelter during rain. The cats used roads and green spaces less than expected from the amount available in the surrounding landscape. Even so, roads still form part of many ranges and could influence how far the outer boundary extended. A different setting can produce a different pattern. In 2026, researchers tracked 49 neutered-owned cats for 7 days in a Mediterranean landscape. Their average range covered about 0.85 hectares. That area is similar to a circle with a radius close to 50 meters. Cats living near natural or semi-natural open land generally traveled somewhat farther. The researchers found no consistent preference for one mapped land cover type across the whole group. Local layout, nearby barriers, vegetation, human buildings, and individual habits all influenced how each cat used the available space. These studies show why a GPS map must be read alongside the landscape beneath it. A dense line beside a building may represent shelter, access, scent information, or a familiar route used many times. An empty patch on the map may be difficult to cross, exposed to danger, or simply less useful during the tracking period. The neighbourhood now looks less like a flat area surrounding the house. It contains pathways, barriers, sheltered pockets, and elevated viewpoints arranged into a personal network. Even along the same street, those networks can differ sharply. One cat may spend nearly all of its time among 3 connected gardens. Another may pass through the same gardens before continuing across a road and into open fields. The surrounding structures shape the opportunity, while the individual cat determines how far that opportunity is used. Placed over the same row of houses, 2 GPS tracks can look as though they came from different species. One forms a tight knot around several gardens. The other stretches across roads, fields, and long strips of open ground before bending home again. An average range can hide this difference. A few long-ranging individuals may account for much of the outer movement recorded in a study, while most cats remain considerably closer to home. The behaviour of one pet cannot be predicted from the group average alone. A detailed example comes from Denmark, where researchers fitted 97 companion cats with GPS trackers for about 7 days. The median cat spent approximately 5 hours away from home during each day. Median means the middle result after all the cats are placed in order, with half above it and half below. That middle cat travelled around 2.4 kilometers per day. Its 95% home range covered about 5 hectares. The 95% figure removes the most unusual outer points and focuses on the area containing nearly all regular movement. Daily travel still varied greatly. The middle half of the cats covered between 1.3 and 3.7 kilometers per day. That is a wide span among ordinary household pets living within the same country. A cat walking 1.3 kilometers may complete several loops through nearby properties. Another covering 3.7 kilometers can travel almost 3 times as far while still returning to the same food bowl and sleeping place. Age helped explain part of the difference. Cats older than 7 generally spent less time outdoors, moved shorter daily distances, and used smaller home ranges than younger animals. Several changes may contribute. Older cats can develop stiffer joints or recover more slowly. After climbing and running, long experience may also produce a settled routine, with fewer exploratory trips beyond familiar paths. Health, confidence, and the arrangement of nearby resources can influence the pattern as well. A healthy 10-year-old cat with years of outdoor experience may still roam farther than a cautious 3-year-old living beside a busy road. Reproductive status created another clear influence. Intact males, meaning males that had not been neutered, spent more time away and used larger ranges than neutered cats. Mate searching can pull an intact male beyond its usual feeding and resting area. The scent of a receptive female may encourage travel across several overlapping ranges. Competition with other males can also shift routes and increase movement during the breeding period. Neutering often reduces this reproductive pressure, though it does not erase exploration or hunting. The surrounding landscape determines how far those motivations can be expressed. Cats with access to natural or partly natural areas in the Danish study spent more time outside, travelled farther, and occupied larger ranges. A line of houses may limit movement through walls, fences, traffic, and closely packed neighbouring cats. Fields, woodland edges, and quiet rural lanes can provide longer connected routes with fewer solid barriers. Available space alone does not guarantee that a cat will use it. The animal must still have a reason to continue. Individual habits can become powerful over time. A skilled hunter may repeatedly visit a ditch where mice move through tall grass. A bold cat may cross an open driveway that another avoids. Early outdoor experience can make certain surfaces, sounds, and obstacles feel familiar. Neighboring cat density may close one route, while leaving another relatively peaceful. Feeding schedules can shorten a journey when the cat expects a meal at a predictable hour. A sheltered bench, greenhouse, or hay-filled outbuilding may pull the range outward by providing a dependable resting place. These factors do not always appear as strong statistical predictors because they can be difficult to measure across dozens of homes. They still help shape the route of a particular animal. The final map grows from the meeting of motivation and opportunity. Age and reproductive condition affect the drive to travel. Roads, fields, fences, and neighboring animals control where that drive can lead. Each track records one cat solving one landscape through repeated choices. Some solutions remain compact enough to fit inside a few gardens. Others extend across several hectares before narrowing toward home. Every journey, regardless of size, depends on the cat keeping track of its position and finding the same doorway again. At the far edge of a familiar route, the cat may pause beside a hedge or beneath a parked vehicle. The doorway is no longer visible. Several buildings now block the direct view home, and the path has curved through more than one garden. The return still begins with information gathered during earlier trips. A cat that has used the same area for months may recognize the slope of the ground, the texture beneath its paws, and the opening between two fences. Nearby sounds can also provide stable clues. Traffic comes from one direction. A ventilation fan hums behind a building, and a familiar dog barks from a particular yard. Smell adds information from plants, soil, household activity, and other animals. No single clue needs to carry the entire journey. Several imperfect signals can work together. A hedge may lead toward a shed. The shed stands beside a narrow lane. A gap beneath the final fence opens into a garden, where the cat can see a familiar tree or roofline. This kind of connected memory may be more useful than a human-style map viewed from above. The cat can learn a sequence of places and movements. Turn beside the wall, pass through the opening, follow the covered edge, then cross the garden. Researchers call this ability spatial memory. Spatial memory allows an animal to remember where useful places are located and how they connect. Laboratory tests have shown that cats can remember locations they recently visited, including places where food was hidden. Outdoor navigation extends that ability across a larger and more complicated setting. The route changes slightly from day to day. A gate may be closed. A vehicle may block a usual passage. Heavy rain can fill a shallow ditch. A cat with several remembered routes can adjust without becoming lost each time the landscape changes. Self-motion may provide an additional guide. Animals can gather information from their own turns, speed, and direction while moving. The process is often called path integration. A simple example can be imagined as an animal walking 10 meters forward, turning right, then traveling another short distance. Information from those movements may help it maintain a rough estimate of the direction back toward the starting point. The estimate becomes less accurate as errors build during a long or complicated route. Visible landmarks and other local clues can correct those errors. Path integration has been studied clearly in animals such as desert ants, which travel away from their nests along twisting searches and then return by a much straighter path. Cats may also use information from their own movement during short journeys, though this has not been proven as a complete explanation for feline homing. Daily travel through a known neighbourhood differs from finding home after being carried to an unfamiliar place. A cat following learned fences and gardens is using previous experience with that area. A displaced cat begins without those familiar local landmarks. Historical reports describe cats returning after travelling surprising distances, sometimes after families move to a new home. Such accounts can show that a return occurred. They rarely reveal the route, the sensory clues, or the number of failed attempts. A cat might follow roads, encounter familiar scents, receive food from people, or gradually enter an area it recognizes. Without continuous tracking, the mechanism remains uncertain. Earth's magnetic field has sometimes been proposed as part of feline navigation. This invisible field has direction and strength, and several animal groups can detect parts of it. Migratory birds use magnetic information during long seasonal journeys. Sea turtles also appear able to respond to magnetic features associated with different parts of the ocean. Domestic cats do not yet have the same level of experimental evidence. A magnetic sense remains possible, though it has not been demonstrated as a dependable compass explaining ordinary returns home. The strongest explanation for most daily journeys remains a combination of learned routes, spatial memory, self-motion, sound, and smell. These systems can overlap. A familiar roofline may confirm a direction first estimated from movement. The scent of home may become more noticeable as the cat approaches. Regular household sounds can narrow the final part of the route. The return is impressive because it depends on many small pieces of information being joined over time. Researchers can draw the track with great accuracy once the collar is collected. Identifying the exact cue guiding each turn remains much harder. The landscape remembered by the cat also contains information that no satellite image can display. Posts, trees, walls, and gateways carry chemical traces left during earlier journeys and by other animals using the same paths. At a fence corner beside a well-used path, the cat slows and lowers its nose toward the wood. Nothing obvious has changed since the previous visit. The post still leans at the same angle, and the narrow opening beneath it leads into the same garden. Its surface may now carry chemical traces left by another cat several hours earlier. Cats place these traces in several ways, and each behaviour can serve a somewhat different purpose. A cat rubbing its cheek against a post deposits small amounts of material from scent-producing glands around the face. Similar glands occur near the lips, beneath the chin, along the forehead, and close to the base of the tail. When the body slides around a corner or against a person's leg, some of these secretions can remain on the contacted surface. the amount may be too small for a person to notice. A cat's nose can detect chemical differences that remain hidden to human senses. Urine spraying leaves a more concentrated sample. During spraying, a cat usually stands with its tail raised and directs a small amount of urine backward onto a vertical object. Tree trunks, walls, gateposts, and the corners of buildings can hold the scent above ground, where another cat's nose can reach it easily. Spraying occurs in females and neutered animals as well, although intact adult males often perform it more frequently. Scratching changes the same landscape in another way. The claws cut visible lines into bark, wood, or another suitable surface. Glands around the paws may leave additional chemical material near the scratches. A marked tree can therefore provide a visual sign and a scent signal in the same place. Soft bark accepts deeper grooves, which may help explain why some trees receive repeated use while nearby trunks remain almost untouched. Field observations by animal behaviour researcher Hilary Feldman followed semi-feral domestic cats living with limited human contact. Adult males performed most of the recorded urine spraying. Scratched trees were commonly found beside paths the cats already used for travel. They did not form a clean ring around the outer edge of each cat's range. Cats also rubbed against objects along their routes, adding another type of trace to familiar places. These observations show why every mark should not be described simply as a border sign. A cat's outdoor range often overlaps with those of several neighbours. Chemical deposits may help animals monitor this shared space by showing that a particular cat has passed through recently. The mark can remain after the animal has moved far beyond the area. A second cat receives the information without meeting the first one directly. Elimination adds another possible source of scent, though its meaning varies with context. Cats often bury feces by scraping loose soil or litter over them. In Feldman's observations, most feces were covered and were frequently placed away from the central area used most heavily. That pattern does not fit a simple system in which every dropping announces ownership of a defended boundary. Urine used for ordinary elimination can also differ in placement and posture, from urine sprayed onto an upright surface. The cat encountering a mark may sniff closely for several seconds. Its nose gathers airborne molecules, while another sensory structure can help examine particular chemical compounds. This structure is called the vomeronasal organ. It sits inside the roof of the mouth and connects with passages near the nose. During a response sometimes called phlegmon, a cat may hold its mouth slightly open, lift its upper lip, and remain still. This movement may help bring chemical material toward the vomeronasal system. The expression can look unusual because the cat appears to pause with its mouth partly open. The signal being examined may contain information related to identity, sex, reproductive condition, or how recently the other animal passed. Researchers have not translated every scent into a fixed message. The meaning also depends on where the mark appears and which cat discovers it. A familiar household companion may receive a different response from an unknown adult male. A fresh spray beside a feeding route may matter more than an older trace weakened by rain and sunlight. Each visit can update the cat's understanding of the area. The fence corner now carries more than its shape and location. It holds evidence of recent movement through a place used by several animals. The cat can continue along the route without seeing the neighbour whose presence has just been detected. These delayed exchanges fill gardens and lanes with social information. Every home range sits among other ranges that contain their own routes, resting places, and chemical records. The cat that left the fresh scent may already be resting several houses away. Its route can still cross the same garden again later, perhaps after the first cat has returned home. When researchers place several GPS tracks over one map, the lines often overlap across lawns, fences, sheds, and narrow passages. Shared ground does not automatically mean that the cats travel together or belong to one social group. It shows only that more than one animal uses the same location. A garden can serve several cats for different reasons. One may rest beneath a shrub where the soil remains dry. Another might cross the lawn on the way to a feeding place. A third may visit the fence because it offers a raised view of the neighboring yards. Their separate purposes can bring them through the same few meters of land without creating a close relationship. Timing reduces the chance of a direct meeting. One cat may complete its usual circuit shortly after breakfast. A neighbor might pass through during the afternoon, when the first animal is asleep indoors. Another could use the garden after sunset, leaving behind scent information that remains until morning. Researchers sometimes describe this arrangement as temporal separation. The word temporal refers to time. Animals can share a physical place by using it during different hours. Cats may learn these patterns through repeated experience. A familiar scent can reveal that another animal visited recently. Regular sightings may show when a neighbor usually appears. Household schedules also create predictable movement. A cat released before its owner leaves for work may use the area at a different time from one allowed out only after dinner. Occasional meetings still occur when routes and schedules cross. The earliest response may be almost motionless. One cat freezes and watches while the other remains near a fence or doorway. Their ears, tails, and body posture provide information before either animal moves closer. A direct stare can increase tension. Turning partly sideways reduces the frontal approach and allows a cat to prepare for retreat. Waiting may continue for several minutes. One animal eventually moves away, changes direction, or allows the other to pass. This quiet adjustment can prevent a more costly conflict. If neither cat withdraws, the encounter may grow louder. Low growls, hissing, and drawn-out calls communicate increasing discomfort. A short rush or chase can move one cat out of the immediate area. Swatting usually requires closer contact. Physical fighting carries risks that include bites, scratches, and infection. So many encounters end during the earlier stages. The overlapping ranges measured in southern Norway show how often these negotiations may become possible. 92 owned cats were tracked across the same residential landscape. Their combined ranges covered much of the neighborhood, with several animals using many of the same gardens and paths. Male cats had average home ranges of 3.7 hectares. Female ranges averaged 1.5 hectares. A larger range can cross the routes of more neighbors, which may give some males more opportunities for social encounters. These values describe averages across the group. They do not mean that every male traveled farther or met more cats than every female. An individual's response also depends on who the other cat is. Two animals from the same household may rest close together outdoors or follow part of a route as companions. A familiar neighbour can be recognised through repeated scent and sight, allowing both cats to predict each other more easily. A stranger introduces greater uncertainty because its usual routes and reactions are unknown. An unowned cat passing through the area may behave differently from a well-fed pet that expects to return indoors soon. Space and resources influence tolerance. A wide garden with several exits allows cats to keep their distance. A narrow passage between fences can force them closer together. Food left outdoors may draw several animals to one point, increasing the chance of competition. Shelter, warm surfaces, and reliable hunting places can also become valuable enough to attract repeated visits. The neighbourhood, therefore, contains a social arrangement that changes throughout the day. Cats divide shared ground through timing, route choice, recognition, and gradual warning signals. Their paths can overlap heavily, while direct meetings remain brief or uncommon. Knowing where another cat travels provides only part of this arrangement. The hour at which it appears can decide whether a shared garden feels empty, familiar, or occupied. By late afternoon, the shared garden may belong to a different set of visitors than it did that morning. A cat that crossed the lawn shortly after sunrise may now be sleeping indoors. Another appears near the hedge as daylight begins to fade. Domestic cats can be active during both day and night. They are often described as crepuscular, a word meaning that activity tends to rise around dawn and dusk. Those periods can be useful because changing light provides cover, while many prey animals are also moving. A crepuscular pattern is only a starting point. Life with people can shift a cat's schedule by several hours. A pet may learn that the back door opens at 6 in the morning. The sound of a food container can bring it home before its owner leaves for work. Evening meals, children returning from school, and a regular nighttime curfew can all become dependable time signals. Repeated routines allow the cat to predict when outdoor access will begin or end. The human household therefore influences movement even after the animal has passed beyond the property. Traffic creates another daily pattern. A road may be relatively quiet before breakfast and crowded during the morning commute. Pedestrian activity increases near schools, shops, or parks at particular hours. Dog walking often becomes more common before work, and again during the early evening. A cat can gradually learn when a route carries the greatest disturbance. Useful outdoor resources also follow their own clocks. House mice often become more active after darkness settles. Small songbirds usually feed during daylight and may gather beneath bird feeders soon after sunrise. Moths and other night-flying insects appear around outdoor lamps. Warm pavement can remain comfortable after sunset, while a shaded surface may become useful during a hot afternoon. A garden that offers little activity at noon can become a busy hunting or observation place several hours later. The cat's internal body clock helps organize these changes. Light entering the eyes sends timing information to the brain. This helps coordinate sleeping, activity, appetite, and hormone release across roughly 24 hours. The system is called a circadian rhythm. Circadian comes from Latin words meaning approximately 1 day. The rhythm adjusts when the cat repeatedly experiences new feeding times, changing daylight, or a different household schedule. This flexibility explains why two cats living side by side may use the same area at very different hours. One may spend most of the night indoors because the cat flap is locked. Its neighbour might have free access and begin a longer circuit after midnight. A third cat may roam mainly during the day because it follows its owner outside each morning. Researchers in southwestern Ontario separated GPS locations into daytime and nighttime groups to compare how cats use space. The tracks did not reveal one universal pattern in which every cat entered a much larger or completely different range after dark. Some individuals changed their movement noticeably. Others used similar parts of the neighbourhood during both periods. Their schedules reflected a mixture of local conditions and personal routine. This matters because the phrase nocturnal cat can create an overly simple picture. A cat seen sleeping through much of the afternoon may still complete several active trips before sunset. Another may sleep indoors all night after spending the morning moving through nearby gardens. Total activity depends on more than darkness. Age, access rules, feeding time, weather, prey, and the presence of other animals can all shift the outdoor clock. Timing also helps reduce social conflict. A narrow passage behind two sheds may be used by one cat during the afternoon. Several hours later, another follows the same route and finds only a fading scent. Both animals share the physical corridor while avoiding a direct encounter. Regular timing can make these arrangements surprisingly stable. A cat may wait near a window until a familiar neighbour has passed. It can delay a garden visit until dogs have returned indoors. Later, it may shorten a trip because the usual evening meal is approaching. The map around the house changes with every hour. A sunny wall becomes a warm resting place in the morning. The same wall offers shade after the sun moves behind the building. After dark, the base may become a route for mice and insects. Light, temperature, human movement, and animal activity continually alter what each location can provide. Even a well-established daily routine remains sensitive to larger changes. Rain can reduce travel within a single afternoon. A heat wave may push activity toward cooler hours. Winter darkness and spring breeding behaviour can reshape the schedule across entire months. The outdoor clock keeps time, but weather and season continually adjust its hands. Heavy rain can interrupt a routine before the cat has travelled beyond the garden. Water striking leaves and roofs fills the air with a steady layer of sound. Quieter movements beneath grass become harder to separate from the background. The ground softens, familiar surfaces grow slippery, and shallow hollows begin to collect water. Scent also changes. Rain can dilute chemical traces on walls, posts, and vegetation. Flowing water may carry some odors away from the place where they were deposited. High humidity can help certain scent molecules remain noticeable, though a heavy downpour can alter the entire chemical picture within minutes. Visibility changes beneath dark clouds and moving curtains of rain. Dry shelters become more valuable. A cat may remain beneath a porch, greenhouse, vehicle, or thick evergreen shrub while waiting for conditions to improve. Its coat provides insulation by holding a layer of warm air close to the skin. Once the fur becomes soaked, water replaces part of that trapped air. Heat then escapes more quickly especially when wind moves across the wet coat. A 4-kilogram cat has a much larger surface area compared with its body mass than a human does, so exposure can cool the body relatively quickly. Movement itself also costs energy. Walking through wet vegetation presses cold water against the legs and underside. Mud reduces traction. A jump onto a slick fence requires more care than the same movement on dry wood. These small costs can make a familiar route less useful for several hours. GPS records from 97 companion cats in Denmark showed this change clearly. On days without rain, the cats travelled an average of about 3.6 kilometres. During heavy rainfall, the average fell to approximately 2.4 kilometres. That difference is close to 1/3 of the dry day distance. The result does not mean that every cat stayed indoors. Some continued moving through sheltered paths, while others shortened their circuits or spent longer periods beneath cover. The value of the trip had changed. Prey may also respond to the weather. Small mammals can remain inside burrows during periods of intense rain. Birds often reduce exposed feeding, while seeking protection in dense vegetation. Flying insects become less active when water, wind, or low temperature makes controlled flight difficult. A hunting place that was productive the previous evening may offer little movement during a storm. Dry resting sites become more important at the same time. A shed containing warm machinery, a covered deck, or a neighbour's open garage can draw the cat away from its usual route. Weather therefore changes both the cost of travelling and the location of useful resources. Temperature creates a similar balance. During summer heat, pavement and dark roofing can become uncomfortable beneath the paws. Shade, damp soil, and airflow beneath buildings gain value. Activity may shift toward early morning or evening as the ground cools. Cold weather increases the energy needed to maintain body temperature. A cat may still travel in winter, though pauses in sheltered sunlight or warm outbuildings can occupy more of the trip. Seasonal change extends beyond temperature. Spring vegetation grows taller and creates new concealment along garden edges. Young birds begin leaving nest during a limited period when their flight is still developing. Juvenile mice and voles also become more common at certain times of year. Warm months bring beetles, moths, grasshoppers, and other insects into outdoor routes that seemed empty during winter. Day length changes the number of hours available under particular light conditions. Reproductive behaviour can alter movement as well. An intact male may extend its range when females are receptive, while a neutered cat is less affected by mate searching. No single season produces the greatest roaming everywhere. A Danish winter may bring cold rain, short daylight, and frozen ground. Summer in Georgia can bring heat, reptiles, and long evenings filled with insects. A Mediterranean spring may provide mild temperatures, while vegetation and prey activity rise together. Local weather combines with landscape, access rules, prey, and individual habit. The cat responds to that combination during every trip. A route remains useful only while its possible rewards justify the energy, exposure, and discomfort required to travel through it. The map around the house can therefore expand during 1 week and contract during the next. The animal making those adjustments carries a set of hunting senses and movements shaped long before modern houses, roads, or weather forecasts existed. Beneath a porch or thick shrub, a waiting cat can become almost motionless. Its ears remain active while the body stays low and sheltered. A small sound in wet grass may cause the head to turn before the paws move at all. That posture connects the modern pet to a wildcat lineage shaped by patient hunting. Domestic cats descend mainly from the Near Eastern and North African wildcat, commonly called Felis sylvestris libica. This slender wildcat has sandy or grey-brown fur, faint stripes, and a body well suited to dry grasslands and scrub. Its prey includes rodents, small birds, reptiles, and large insects. Thousands of years ago, some of these wildcats began spending more time near human settlements. Early farming communities stored grain in houses and clay containers. Spilled grain supported growing populations of mice. Rodents attracted cats, while people gained a hunter that could move quietly through storage areas. The relationship probably developed through many small contacts, rather than one planned act of domestication. Cats that tolerated nearby people could reach concentrated prey around settlements. Humans had reason to allow useful hunters to remain. One of the clearest early signs of this relationship comes from Shilurikambos, a Stone Age settlement on the island of Cyprus. Archaeologists found the remains of a cat buried close to a human. The burial dates to roughly 9,500 years ago. Cyprus had no native population of these wildcats, so people must have carried the animal or its ancestors across the Mediterranean by boat. That journey shows that cats had already become valuable enough to transport between lands. The burial suggests a close connection, though it does not describe a modern pet sleeping beside a food bowl. Domestic cats spread gradually through several regions. Near Eastern cats traveled alongside early farming communities. Egyptian populations later became important around settlements, ports, and trade routes. Ships offered another useful setting because grain stores attracted rats and mice. Cats carried aboard vessels could protect food while also reaching new coastlines. Ancient DNA shows that the history involved movement between populations over long periods. Domestication did not begin on one exact day or inside one single village. Human contact increased through farming, trade, transport, and repeated breeding near settlements. During this process, cats changed less in body shape and hunting behavior than many domestic animals. Cattle, sheep, and pigs were selected strongly for food production. Dogs were shaped into specialized forms for guarding, herding, scent work, and companionship. Cats remained useful largely because they already possessed the behavior people valued. Their small bodies fit into storage spaces. Sensitive hearing helped locate rodents hidden behind walls. Sharp claws and rapid pouncing made them effective hunters without extensive training. Regular feeding later changed how strongly survival depended on catching prey. A household cat can receive enough energy from prepared food and still react to movement outside. Hunger and hunting motivation overlap, though they arise from partly separate systems. Experiments have shown that hungry cats may be more likely to complete a kill. A well-fed cat can still orient toward a sound, lower its body, stalk, chase, and pounce. Movement itself can trigger attention before hunger becomes important. This explains why a cat may hunt after eating a full meal. The food bowl removes the need to depend on prey for daily calories. It does not erase the sensory and motor sequence built through evolution. Young cats often practice parts of that sequence during play. They hide, rush forward, grab moving objects, and adjust the strength of the bite. Experience improves timing and control. Outdoor access then places the same abilities beside living prey. The animal returning for warmth and food remains connected to a predatory history that began long before houses had windows or gardens had fences. Human care made the cat safer and more dependable as a companion. The hunting system remained ready for use whenever movement crossed its path. A faint rustle in grass can interrupt an ordinary patrol within a fraction of a second. The head turns, the body lowers, and travel becomes a carefully ordered hunt. A faint movement beside the path can change the cat's behaviour within a fraction of a second. One ear turns toward the sound before the rest of the body follows. The head shifts, the eyes fix on one point, and the cat becomes still. This first stage is called orienting. The animal is trying to identify where the movement began and whether it is worth approaching. Sound can provide direction even when grass or leaves hide the source. A cat's outer ears can rotate independently, helping it compare the timing and strength of a noise reaching each side. Small differences allow the brain to narrow the possible location. Vision then becomes more important if the prey moves into view. The cat may hold its gaze on a single patch of ground. This steady attention is called fixation. A flicking tail, twitching grass stem, or brief movement beneath a shrub can keep the animal focused for several minutes. Once the target is located, the body begins to lower. The legs bend, the belly moves closer to the ground, and forward steps become slower. This is the beginning of stalking. A low profile makes the cat harder to see. Careful foot placement also reduces noise from dry leaves, gravel, or brittle stems. Pauses become part of the approach. When the prey looks up or stops moving, the cat may freeze. Movement resumes after the target relaxes or turns away. Some hunts rely on ambush. The cat waits beside a burrow, bird feeder, or narrow trail until prey comes within reach. Other hunts involve active pursuit, with the cat following movement through grass or across open ground. The final approach depends on distance and cover. As the cat prepares to spring, the hind limbs fold beneath the body. Large muscles around the hips and thighs store force for rapid acceleration. The spine can flex during the launch, helping lengthen the stride. A short chase may follow if the prey begins running. At closer range, the cat may leap directly forward or strike with one forepaw. The pounce brings the body over the target while the front paws attempt to block escape. Capture begins when the prey is held beneath a paw, trapped between both front feet, or caught in the mouth. The handling stage can vary greatly. A cat may pin the animal and adjust its grip. Some prey is released and caught again. A mouse can turn and bite, while a bird may escape upward if one wing remains free. Reptiles may twist or shed part of the tail. Large insects can cling to grass or produce defensive chemicals. Prey size and behavior therefore affect what happens after contact. Experience matters as well. A skilled adult may control a mouse quickly. A younger cat may hesitate, release it too early, or treat part of the encounter like play. Interruption can also change the result. A passing person, barking dog, or approaching vehicle may cause the cat to abandon the prey before the sequence is complete. Hunger can increase the likelihood that a cat continues toward a kill or eats what it catches. Experimental studies have found that hungry cats were more likely to complete the killing stage. Larger prey and animals capable of strong defense lowered that probability. Fed cats still attacked and killed in some trials. The sight or sound of moving prey can activate hunting behaviour even when the cat has already consumed enough calories. Each stage can therefore be influenced separately. A cat may orient without stalking. A stalk may end before the pounce. Contact with prey may fail to produce a secure capture. A captured animal may escape during handling. Even a confirmed kill can end in several ways. The cat may eat part of the animal where it was caught. It may leave the body beneath vegetation, carry it a short distance, or transport it toward home. These differences matter when researchers try to count outdoor hunting. An owner who finds a mouse near the door sees only one possible outcome. The unseen sequence may have included several failed stalks, one abandoned capture, and another prey animal consumed outside. For many years, the final object brought home provided most of the available evidence. Small cameras carried by the cats eventually allowed the missing stages to be watched from the beginning. The first clear view of those hidden stages came from a small camera attached beneath a cat's neck. From November 2010 through October 2011, researchers followed owned free-roaming cats in suburban Athens, Georgia. 55 cats took part in the project. Each one wore a lightweight video device known as a kitty cam. The camera faced forward and downward, recording the ground, nearby vegetation, other animals, and part of the cat's own movements. Owners placed the device on their cats before outdoor trips and removed it when the animals returned. Each participant was observed for 7 to 10 days. The researchers collected an average of about 38 hours of usable outdoor footage from each cat. Across the full group, this added up to more than 2,000 hours of recorded behaviour. A GPS point can show that a cat spent 10 minutes beside a hedge. The camera can reveal whether those minutes involved resting, grooming, watching another cat, or following movement beneath the leaves. That extra context made it possible to separate travel from hunting. 44% of the cats displayed at least one hunting behaviour during their observed week. They oriented toward prey, stalked, chased, or attempted a pounce. 30% of the full group successfully captured wildlife. The gap between those two figures matters. Several cats began the hunting sequence without completing a capture. The prey moved away too soon, disappeared beneath cover, or escaped after contact. Other cats showed no recorded hunting behaviour during their observation period. Outdoor access, therefore, did not produce the same result in every animal. Among the successful hunters, the average was about 2.4 captured prey animals during 7 days of roaming. Some caught only one. A smaller number captured several and accounted for a larger share of the total. This variation is important whenever outdoor cats are discussed, as though every individual hunts at the same rate. The prey found around Athens reflected the wildlife available in that part of Georgia. Reptiles formed a large part of the recorded captures. Small mammals and invertebrates also appeared regularly. The Carolina anole was the most commonly captured individual species. This small lizard usually grows to around 13 to 20 centimeters long when its tail is included. It can change between shades of green and brown, helping it blend into leaves, bark, and fences. Carolina anoles are active during daylight and often move across low vegetation or sunlit surfaces. That behaviour places them within reach of a cat, travelling through gardens and along building edges. Mice and voles required a different type of approach. They were more likely to be detected through sound or movement close to the ground. Large insects could trigger short chases or quick paw strikes. The camera showed that hunting behaviour changed with the prey encountered, rather than following one fixed pattern. Season also shaped the results. 85% of recorded captures occurred between March and November. Those warmer months in Georgia bring greater activity from reptiles, insects, and many small mammals. Vegetation becomes denser, daylight lasts longer, and cats may spend more time outdoors under comfortable conditions. The winter footage contained fewer captures because the local supply and visibility of prey had changed. These numbers belong to one place and one period. A camera study in a colder northern city could record more rodents and fewer reptiles. An island with native ground-living birds could produce a very different prey list. Local ecology determines which animals cross the cat's route. The KittyCam project also revealed ordinary behaviour between hunts. Cats rested beneath vehicles, entered crawl spaces, drank from outdoor containers, and watched other animals without attacking them. Much of the recorded time involved travel or waiting, rather than predation. The camera replaced a blank space in the daily story, with hours of visible detail. It showed that many cats did not capture wildlife during the observed week. It also showed that successful hunters could make repeated captures within a short period. The animal later found beside a doorstep represented only one possible ending. Most completed captures followed other paths that never carried the prey through the household door. After a successful capture, the outcome can move in several directions. A small animal may be eaten where it was caught. The body may remain beneath a hedge, beside a fence, or in long grass. A cat can carry the prey for part of the route, then drop it after hearing a dog, vehicle, or approaching person. Some captures reach a porch or kitchen floor, where the owner finally sees evidence of the hunt. The KittyCam footage from Athens, Georgia, showed how unevenly these outcomes were divided. Only 23% of recorded prey were carried home. 49% were left at or near the capture site. The remaining 28% were consumed. A prey animal found inside the house therefore represented less than 1/4 of the completed captures recorded by the cameras. The larger share remained outdoors. This creates a challenge for researchers because household observations are much easier to collect than complete outdoor records. An owner can write down every mouse, bird, lizard, or insect found near the door. The same person cannot watch every minute spent beneath shrubs, behind garages, or across neighbouring properties. A week with no prey returned home may still contain several hunting attempts. The cat might stalk without making contact. A captured insect could be eaten immediately. A mouse might escape during handling, while a small reptile could be abandoned beneath vegetation. None of these events would appear in a household prey count. This difference is called detection probability. Detection probability describes the chance that an event will actually be noticed and recorded. A returned animal has a high chance of being seen. A capture beneath a distant hedge has a much lower chance unless the cat is carrying a working camera. Low recorded numbers can therefore reflect limited observation as well as limited behaviour. Prey return studies still provide useful information. Owners can participate for several weeks or months without expensive tracking equipment. Large numbers of households can record the same type of evidence using simple instructions. Researchers can then compare how many animals appeared before and after a change in food, play, collar equipment, or outdoor access. The method becomes especially valuable when the same cats are observed in the same way across both periods. A reduction in return prey may show that the intervention changed at least one visible part of the hunting outcome. The count should remain clearly labelled as prey brought home. It cannot automatically stand for every animal stalked, captured, injured, or killed outdoors. Cameras improve the view, though they also leave gaps. A collar can rotate until the lens points toward fur or sky. Rain, dirt, and vegetation may block the image. Battery power limits the number of hours recorded. The device can fall off when a breakaway collar opens, which is designed to protect the cat if the collar catches on a branch or fence. Added weight may slightly change movement, especially during climbing or rapid pursuit. Some cats refuse to wear the equipment at all. GPS tracking reveals a different portion of the journey. A cluster of location points beside a shed may show that the cat remained there for 20 minutes. The points cannot reveal whether those minutes involve sleep, grooming, waiting, or a hunt. A camera can supply behavioral detail while recording only the area within its narrow view. The prey may move outside the frame at the most important moment. Direct human observation creates its own influence, because a nearby researcher may change the behavior of both cat and prey. Every method opens one window and leaves another partly closed. Researchers improve confidence by combining several forms of evidence. GPS can show where repeated activity occurs. Video can identify what happened during part of that activity. Owner records can extend observation across longer periods and many households. The remaining uncertainty must be included when larger estimates are calculated. A small home range can appear quiet when only doorstep returns are counted. Camera footage reveals that some of its hunting activity remains scattered beneath cover and along familiar routes. Repeated captures are therefore concentrated inside the same limited patch of gardens, buildings, and vegetation. Once those unseen outcomes are included, the ecological weight of a short journey begins to grow. Inside that compact patch of gardens and buildings, each capture is concentrated within a surprisingly small area. The International Cat Tracker project followed 925 owned cats across 6 countries. Their average home range covered about 3.6 hectares. That is roughly the area of 5 standard soccer fields, though many individual cats used less. 75% of the animals spent their outdoor time in ranges, made up of at least 90% disturbed habitat. Disturbed habitat means land heavily changed by people. It includes residential streets, gardens, parking areas, farm buildings, and the narrow strips of vegetation between them. These places may look ordinary, but they still support many small animals. House mice shelter inside walls and sheds. Voles move through grass and low plants. Young birds spend time on lawns or beneath shrubs while learning to fly. Lizards, beetles, and moths can gather around warm walls and outdoor lights. A hunting cat repeatedly encounters this wildlife close to the same home. Owners taking part in the international study reported an average of about 3.5 prey animals brought home by each cat every month. That number describes only the animals people found. The camera studies showed that other captures may be eaten outdoors or left where they were caught. Researchers therefore calculated a range of possible total effects rather than relying on one exact figure. For the participating cats, the estimated rate was between about 14.2 and 38.9 prey animals per hectare each year. A hectare is 10,000 square meters. The lower estimate assumes that owners saw a larger share of the total captures. The higher estimate allows for more prey remaining unseen outdoors. These numbers describe the intensity of predation across the area used by the cat. A simple yearly total can hide this spatial detail. Imagine that two predators each capture 20 small animals during 1 year. The first ranges across several square kilometers. Its captures are spread over fields, woodland, and stream edges. The second repeatedly hunts inside a few connected gardens. The number of captures may be equal, while the pressure within each hectare differs greatly. A wild predator also depends more directly on the prey available in its environment. When prey becomes scarce, the predator may travel farther, reproduce less successfully, or struggle to survive. Its population is partly limited by the amount of food the landscape can supply. An owned cat receives calories from a bowl indoors. People also provide shelter, warmth, and veterinary care. This support is sometimes called a subsidy because resources from outside the ecosystem help maintain the animal. The cat can continue living at the same house even when it catches very little wildlife. Hunting remains possible whenever prey appears, while survival does not depend on those captures. This does not mean that every pet cat catches more animals than every native predator. Many owned cats hunt rarely, and some show no successful hunting during a tracking period. A smaller group may make repeated captures and account for much of the total. The important feature is concentration. A persistent hunter can return to the same hedge, bird feeder, drainage ditch, or patch of long grass throughout the year. Its home range may extend only about 100 meters from the house. Within that circle, familiar prey routes are checked again and again. Seasonal changes can bring new opportunities into the same locations. Young birds leave nests in spring and early summer. Rodent populations rise and fall as food and cover change. Warm evenings bring insects onto walls and beneath outdoor lamps. The cat does not need to explore an enormous landscape to encounter fresh prey. The landscape renews itself inside the established route. A nearby garden, therefore, has ecological importance, even when it appears small on a map. It can provide nesting cover, feeding space, shelter, and a passage between larger green areas. Repeated visits from one cat add a steady predatory presence to that limited patch. One compact range creates one local area of pressure. Across a residential neighbourhood, many similar ranges begin to overlap until very little outdoor space remains beyond the reach of a cat. When several home ranges are placed on the same map, their outer edges begin to cross. A second cat's route overlaps the first around a garden fence. Another range reaches across the same row of sheds. More tracks gather around neighbouring houses until the separate shapes form a connected surface. Researchers sometimes call this combined pattern a catscape. A catscape shows how an entire population of cats uses one landscape. Each animal's estimated movements are added to the movements of the others. Locations receiving frequent visits appear as stronger areas on the map. A high point may form because one cat spends many hours there. It can also appear where several animals pass through the same place at different times. This method reveals patterns that remain hidden when every cat is examined alone. Researchers created such a map from the 92 owned cats tracked in southern Norway. The animals lived in the same residential area, surrounded by houses, roads, gardens, patches of vegetation, and small wooded spaces. Their movements were estimated with Brownian bridge models. These models use the time and distance between GPS readings to calculate the most likely corridors connecting them. The individual movement surfaces were then combined. Very few gaps remained within the residential study area, where ground-living wildlife would have been unlikely to encounter any participating cat. One animal might rarely leave the gardens closest to its house. Its neighbour could extend farther toward a road or wooded edge. A third cat might connect those two areas through a narrow route behind several buildings. Together, their ranges reached more of the landscape than any one cat used alone. The strongest areas of the catscape remained close to homes. Each cat's range was anchored to a different residence containing food, shelter, and familiar resting places. The tracked cats spent an average of 79% of their outdoor time within 50 meters of their owners' houses. When many homes sit close together, those 50-meter zones overlap heavily. A lawn may fall near the center of one cat's range, while also lying inside the outer ranges of several neighbors. The same pattern can form around shared fence lines, garden sheds, or strips of vegetation between properties. A bright area on a catscape does not prove that wildlife was killed there. Cats use outdoor locations for many purposes. A warm patio may attract resting animals. The space beneath a parked car can provide shelter. A fence top may serve as a walkway or observation point. The combined map measures possible exposure to cats rather than confirmed predation at every location. Behavioral evidence is still needed to determine what the animals were doing. The population-level view nevertheless changes the experience of smaller wildlife. A mouse leaving one garden may cross the core area of a cat living in the nearest house. Its route through the next property can enter another cat's outer range. A young bird moving between shrubs may pass through several overlapping areas during one short trip. Reptiles swarming beside walls and insects gathering near outdoor lights can experience the same repeated presence. The relevant predator environment is created by the entire local population. One cat may hunt rarely. Another may capture prey several times during a week. Several others may spend most of their outdoor time traveling or resting. Their combined presence still increases the number of places and hours in which wildlife can encounter a cat. This is how modest individual ranges produce a much broader effect. Each home anchors one patch of outdoor activity. Closely spaced homes place those patches beside and over one another. The resulting catscape can cover nearly every connected garden, passage, and open strip within a residential block. The private route that began at one doorway has now widened into a neighbourhood system. It includes dozens of individual schedules, repeated pathways, and overlapping zones of attention. That system also surrounds the cats with dangers of its own. The same roads and confined spaces that connect their ranges can expose them to vehicles, unfamiliar animals, and hazards hidden inside the human-built landscape. Inside the same neighbourhood map, the cat also becomes a small animal moving through hazards created by people. Curiosity can draw it beneath a parked vehicle, through an open garage, or into a narrow drain carrying rainwater beneath a road. Climbing ability opens access to roofs, fences, and sheds. A pursuit can carry the animal beyond its usual route before it has time to judge what lies ahead. The behaviours that make outdoor exploration possible can therefore place the cat in situations that did not exist during most of its evolutionary history. The KittyCam study in suburban Athens, Georgia, recorded these risks directly. Among the 55 owned cats wearing cameras, 45% crossed at least one road during the observation period. 25% encountered an unfamiliar cat. The same proportion ate or drank something away from home. 20% entered storm drains, while another 20% moved into crawl spaces beneath houses. These events were unevenly distributed. Some cats remained close to quiet gardens and showed few recorded risks. Others repeatedly used roads or entered confined structures. One cat crossed roads 24 times while carrying the camera. Each crossing created a brief point where the animal's route intersected with vehicles moving far faster than any natural predator. Cats are built for short bursts of speed. Powerful hind limbs allow rapid acceleration over a few meters. Flexible spines lengthen the stride, and quick turns help during pursuit or escape. These abilities work well when avoiding another animal or reaching nearby cover. A road presents a different problem. A vehicle can approach from beyond the cat's closest field of attention and cover dozens of meters within a few seconds. Engine noise may blend with wind, rain, or traffic coming from another direction. Parked vehicles can block the view until the cat is already close to the roadway. A cat may judge whether it can reach the opposite side, though it has no natural experience with machines traveling at urban or highway speeds. Age and sex affected the recorded pattern in Georgia. Male cats displayed more risk behaviors than females. Older cats displayed fewer than younger animals. The difference may partly reflect range size, confidence, reproductive behavior, or reduced movement with age. A younger male traveling through several neighboring ranges is likely to encounter more roads, strange cats, and unfamiliar structures than an older animal spending most of its time near one garden. Encounters with other cats can also carry consequences. A chase may push one animal across a road or into an area it rarely visits. Bites can transmit infection beneath the skin, even when the wound looks small from the surface. An unfamiliar dog can create the same sudden movement toward a fence, tree, or narrow hiding place. Human structures add quieter dangers. A cat can enter a shed while the door is open and remain trapped after someone closes it. Garages may contain sharp tools, moving machinery, or liquids that are dangerous when swallowed. Antifreeze containing ethylene glycol has a sweet taste and can cause severe poisoning in very small amounts. Rodent poisons can be encountered directly or through poisoned prey. Open containers may hold dirty water, cleaning products, or fuel. Falls are possible around roofs, balconies, trees, and unstable fences. Cats usually control their bodies well during a drop, but height, landing surface, age, and injury can change the result. Cold rain or intense heat becomes more serious if the animal cannot reach shelter. A damaged paw may turn a familiar return route into a much longer journey. These risks do not appear during every outdoor trip. Many cats complete thousands of short circuits and return without obvious injury. Repeated exposure still increases the number of chances for one unusual event to occur. A road crossed every day becomes hundreds of crossings across a year. A garage entered only once may still close before the cat leaves. The outdoor predator therefore remains vulnerable inside the landscape it knows so well. Fast reactions, climbing skill, and close attention help it move through that landscape. Human machines, sealed buildings, and toxic substances can exceed what those abilities evolved to manage. Some outdoor consequences can be seen immediately when the cat returns late, limps, or carries dirt from an unfamiliar place. Others arrive unseen in the coat, digestive system, or bloodstream after contact with parasites and pathogens along the route. A cat may cross the doorway looking exactly as it did when the journey began. Its fur can still carry a flea picked up beneath a porch. A tick may be hidden near the ears, between the toes, or beneath the collar. Other exposures remain deeper inside the body and produce no immediate sign. Outdoor routes bring cats into contact with several possible sources of infection. Fleas can move from another cat, a wild mammal, or a sheltered resting place. Ticks wait on grass and low vegetation, then attach when an animal brushes past. Soil can contain parasite eggs left in feces. Standing water may collect bacteria or microscopic parasites from wildlife. A cat that captures a mouse, bird, or reptile can also swallow organisms already living inside the prey. Direct encounters create additional pathways. A bite from another cat can push saliva and bacteria beneath the skin. Shared feeding areas bring several animals close to the same bowls and surfaces. Gardens, barns, alleys, and wooded edges can all contain biological traces from wildlife that passed through earlier. The connection between these environments is described through an idea called One Health. One Health recognizes that the health of animals, people, and the environment are closely linked. A roaming cat crosses those boundaries repeatedly. It moves through soil, vegetation, prey populations, and the ranges of other animals. Later, it may sleep on a bed, sit on a person's lap, or share indoor space with another pet. This movement can make the cat a bridge between biological communities that would otherwise have less direct contact. A global scientific review published in 2026 brought together information from more than 174,000 cats across 88 countries. The combined records included 124 species of pathogens. A pathogen is an organism or biological agent capable of causing infection. 97 of the recorded species were zoonotic, meaning they can pass between animals and people under suitable conditions. The pooled results showed a clear difference between lifestyles. Outdoor-owned cats had approximately 3 times the odds of infection found among indoor-only cats. About 18.2% of outdoor-owned cats tested positive for at least one pathogen in the combined data. The comparable figure for indoor cats was about 8.3%. These percentages combine many countries, climates, testing methods, and cat populations. They describe a broad pattern rather than the exact risk faced by one household pet. Outdoor-owned cats had pooled infection odds similar to those of feral cats. Feral cats still carried a greater variety of helminths. Helminths are parasitic worms, including roundworms and tapeworms. Their eggs or young stages can survive in soil, prey animals, or intermediate hosts such as fleas. Toxocara cati is one feline roundworm. Adult worms live in the cat's intestine and release eggs through feces. Those eggs require time in the environment before becoming infectious, which makes contaminated soil an important part of the life cycle. Toxoplasma gondii follows a different path. Cats can become infected by eating prey containing the parasite. They may later shed a tough stage called an oocyst in their feces for a limited period. Oocysts can persist in soil or water after leaving the cat. A positive test does not always mean an animal is sick. Exposure means the cat has encountered a pathogen or produced an immune response to it. Infection means the organism has entered and begun surviving or reproducing in the body. Disease develops when that infection causes harmful symptoms or tissue damage. Shedding occurs when the pathogen leaves the animal through feces, saliva, blood, or another route. Transmission to a person requires a suitable pathway and enough contact for the organism to spread. Those steps should remain separate because one does not guarantee the next. Many infected cats remain outwardly healthy. Risk also varies greatly between individuals. A vaccinated cat receiving regular flea, tick, and worm prevention has different protection from an untreated animal. Hunting raises exposure to prey-transmitted organisms. Geography determines which parasites and ticks occur locally. Veterinary care can detect infection early, while prompt treatment can reduce illness and further spread. The outdoor journey, therefore, carries an invisible biological layer alongside its visible roots. That layer depends on prey, soil, climate, neighboring animals, and the care waiting at home. Ownership changes food supply, shelter, vaccination, parasite control, and access to treatment. Those differences explain why cats seen crossing the same field may belong to very different populations, even when their paths briefly meet. 2 cats may cross the same field and face similar parasites, yet the rest of their lives can be completely different. An owned roaming cat has a known home. It receives regular food, shelter, and some level of veterinary care. Its outdoor trip usually begins from one residence and eventually returns there. A stray cat is generally comfortable around people, but currently lacks stable ownership. It may have been lost, abandoned, or separated from a previous home. Some strays continue approaching houses, porches, and feeding places because human contact remains familiar. A community cat lives outdoors and may receive food or shelter from one or more people without belonging to a single household. Several community cats can gather around the same feeding station. Their level of comfort with people varies. Some allow close contact, while others remain several meters away and approach only after people leave. A feral cat usually lives more independently and avoids close handling. Its early development may have included little human contact, making indoor life and direct restraint highly stressful. Barn and farm cats form another broad group. Some are clearly owned and receive daily food. Others are loosely supported because they help control rodents around grain stores, animal feed, and outbuildings. Their ranges can extend across fields, hedgerows, and farm roads far beyond the compact gardens used by many suburban pets. These categories can change during one animal's lifetime. A lost pet may spend weeks as a stray. A stray can join a feeding colony and become a community cat. Regular contact may gradually make adoption possible. A young feral kitten handled early enough can sometimes become comfortable with people. The word outdoor describes where the cat spends time. It does not explain the full history of food, shelter, ownership, or social contact behind that life. Rural tracking studies show how strongly those differences can shape movement. In Portugal, researchers fitted 8 cats with radio collars near farming areas and sensitive wildlife habitat. The animals were followed for an average of about 10 months, much longer than the 7-day tracking periods used in many pet cat studies. Every range remained centered on a farm. The buildings provided shelter, food, and familiar resting places. The cats still traveled far beyond those structures. Their average maximum distance from the farm was about 2.9 kilometers. One recorded journey reached approximately 6.3 kilometers. That distance could carry a cat through several fields and across roads before the route returned toward the farm. The male cats in this small sample used much larger areas than the females. Male ranges averaged about 430 hectares. Female ranges averaged 87 hectares. A hectare covers 10,000 square meters, so even the female average was far larger than the compact residential ranges measured in Norway and Mediterranean neighborhoods. The sample contained only 8 cats, which means the exact averages should be treated carefully. The pattern still shows how reproductive behavior and open rural land can expand movement. During the mating season, male maximum distances averaged about 3.8 kilometers. Outside that period, the average fell to roughly 1.6 kilometers. The search for receptive females can pull an intact male across several neighboring ranges. Neutering usually reduces this reproductive pressure, though hunting and ordinary exploration can continue. Human support also changes the shape of an outdoor population. A reliable feeding site can anchor several cats to one location. Farm buildings provide dry shelter during cold or wet weather. Veterinary treatment may reduce the effects of parasites or injuries. Low housing density leaves fewer walls and closely spaced properties to restrict travel. Open land gives a motivated cat room to continue moving. Containment creates another major difference. A household pet may be allowed outside only during daylight. A barn cat may have access to fields at every hour. A community cat may sleep beneath a building and depend on food left at irregular times. Each arrangement changes the routes, risks, and contacts that appear on the map. A neutered pet crossing two gardens, therefore, represents a different outdoor life from an intact farm cat traveling several kilometers. Both can hunt, meet other cats, and carry pathogens. Their movement grows from different combinations of care, space, reproduction, and dependence on people. Once those lives are separated clearly, outdoor management becomes more precise than a choice between unlimited roaming and complete confinement. Between unrestricted roaming and permanent indoor life, people have created many different ways for cats to experience the outside. Some cats are allowed out only during daylight, when drivers and owners can see them more easily. Others follow a nighttime curfew and return indoors before traffic quiets and small nocturnal animals become more active. Supervised garden time keeps the cat within sight. Harness walking turns the trip into a shared route. Though many cats require weeks of gradual training before accepting the feel of straps and a lead. Enclosed yards use smooth fencing, inward-facing barriers, or overhead netting to reduce escape. A catio provides another option. The name combines cat and patio. These screened structures may attach to a window or door, giving the animal access to fresh air, sunlight, scents, and outdoor sounds without allowing it to roam beyond the enclosure. Each arrangement changes opportunity. A cat behind mesh can watch birds and insects while losing the chance to chase them across neighboring land. A daylight curfew removes some nighttime travel, while preserving familiar daytime routes. Supervision can interrupt a hunt before the final pounce. The useful design depends on the cat, the surrounding landscape, and the risks people are trying to reduce. Restricted access also removes experiences that once filled part of the day. Outdoor cats climb fences, inspect scent marks, search through vegetation, and choose among many resting places. A successful indoor environment needs to replace enough of that variety to keep the animal active and secure. Shelves and tall cat trees provide vertical movement. Covered beds and boxes create places to hide. Scratchers allow claw use and scent deposition. A window perch offers changing views of birds, weather, and people passing outside. Several resting places let the cat move between warmth, shade, quiet, and household activity. Predictable play can supply part of the searching and pursuit sequence. A study led through the University of Exeter tested several methods with 219 households and 355 hunting cats. Owners recorded prey brought home before and during each treatment. One group added 5 to 10 minutes of daily object play. The play used toys that could be chased, caught, and handled, allowing the cat to complete more of the predatory movement sequence indoors. Those cats brought home 25% fewer animals than cats in the control group, and than they had during the earlier recording period. Another group received a food in which meat supplied the main source of protein. Return prey fell by 36%. The exact reason remains uncertain. A more suitable balance of nutrients may have reduced some motivation to search for prey, even when the cats were already receiving enough calories. The study also tested devices intended to warn wildlife. Bright Birds Be Safe collar covers use vivid colors that birds can notice before a cat approaches closely. Cats wearing them brought home 42% fewer birds. The covers produced no clear reduction in mammals, which often depend more heavily on smell, sound, and movement than on bright color vision. Bells also produced no clear effect in this trial. A bell may warn some prey, though grass, wind, collar position, and the cat's slow stalking movements can change how easily the sound is detected. One result moved in an unexpected direction. Cats given puzzle feeders brought home 33% more prey. A puzzle feeder makes the animal work to release pieces of food by rolling, pawing, or moving parts of a container. These devices can still provide useful indoor activity for many cats. In this group of outdoor hunters, the measured prey returns increased. The reason was not established. The feeders may have changed eating patterns, frustration, time spent feeding, or some other part of daily behaviour. This result shows why a reasonable idea still needs direct testing. The Exeter study counted animals delivered to the household. Captures eaten or abandoned outdoors remained unseen. Its design still allowed researchers to compare the same visible outcome across several groups and over time. The findings show that management can act on different parts of outdoor behaviour. Containment changes access. Play may alter motivation and provide practice indoors. Food changes the resources supplied by the household. Bright collar covers increase the chance that certain prey detect an approaching cat. Human choices can therefore reshape the range without assuming that every cat requires the same solution. The route may become shorter, shift into daylight, or remain behind a screen boundary. Even after those changes, a dot recorded beneath a hedge still cannot reveal whether the cat was resting, watching, hiding, or preparing to hunt. Beneath the hedge, several GPS readings gather inside an area only a few meters wide. The cluster looks important, though its meaning remains uncertain. The cat may have slept there while the branches blocked wind and rain. It could have watched another animal through the leaves or waited beside a mouse trail. A fence may have delayed its movement. Nearby walls might also have reflected satellite signals and placed several readings slightly away from the cat's true position. Location alone cannot separate these possibilities. A GPS unit records where the collar probably was and when the reading occurred. An accelerometer adds information about movement. This small sensor measures changes in speed, direction, and the angle of the device. A steady signal may suggest that the cat is resting. Repeated smooth changes can match ordinary walking. Sharp bursts may occur during running, jumping, or a rapid turn. Climbing produces a different pattern because the body changes angle while moving upward. An accelerometer still cannot see the object the cat approached or explain why it suddenly accelerated. A camera supplies part of that missing context. Video may show the edge of a garden, another cat, or prey moving through vegetation. It can reveal grooming when the movement sensor records repeated body motion in one place. Used together, GPS, accelerometers, and cameras provide a fuller description than any single device. Researchers often call this sensor fusion. Fusion means that several streams of information are combined so that the strengths of one sensor help cover the weaknesses of another. The amount of material can quickly become difficult to manage. 50 cats carrying cameras for 40 hours each would produce 2,000 hours of footage. Watching every minute at normal speed would require more than 80 full days without sleep. movement sensors can create millions of measurements during the same study. Machine learning systems may help classify this material. A computer can be trained using examples already labeled by people. After seeing many confirmed periods of resting, walking, grooming, and running, the system searches for similar patterns in new data. Possible hunting may be detected when low movement is followed by a short burst and then close handling motions. These systems remain under development. Unusual behaviour, a loose collar, or an individual cat with a different walking style can lead to mistakes. Human review still matters, especially when the category carries an important ecological meaning. The cat selected for tracking also shape the results. An animal that calmly accepts a collar or harness may differ from one that removes every device. Owners who volunteer for a study may supervise their pets more closely or pay greater attention to hunting than the wider population. A 7-day record can capture a normal week, while missing a journey made once each month. Seasonal changes may remain invisible when tracking occurs during only one part of the year. GPS accuracy often falls near tall buildings, thick tree cover, or narrow spaces between walls. Cameras add weight and can brush against vegetation. Prey counts made by owners omit animals left or eaten outside. Each source of evidence, therefore, contains a particular type of gap. Better detail does not always produce a stronger or simpler claim. In 2026, researchers examined 49 neutered-owned cats in a Mediterranean landscape. They matched the GPS tracks with recent aerial images and fine-scale maps of buildings, vegetation, open ground, and other land types. This allowed the available habitat around each home to be measured with unusual precision. The cats living near natural or partly natural open areas tended to range somewhat farther. Across the full group, however, no single land cover category was used consistently more or less than expected. A broad map might have encouraged a simple statement about preferred habitat. Finer measurements supported a more cautious conclusion. Important parts of outdoor behaviour remain unresolved. Researchers still do not know exactly how a young cat establishes its first regular route. Boldness, early experience, prey success, and neighbouring cats may all contribute. The reason one individual becomes a frequent hunter, while another rarely completes a capture, is also difficult to predict. During a return home, sight, smell, sound, and self-motion information may cooperate, though the cue guiding one particular turn cannot usually be identified. Routes can remain stable for months and then change after a family moves, a fence is built, or a neighbouring cat disappears. A new feeding place may pull the range outward. Age or illness may gradually draw it inward. Scientific uncertainty becomes useful when it marks the exact boundary of current knowledge. The track still reveals distance, timing, repeated places, and the shape of the range. Those measurements have already changed the meaning of the familiar cat approaching its doorway once again. The final cluster of GPS points begins to stretch toward the house. The cat leaves the hedge and follows a narrow line beside the fence. A corner used for scent investigation now helps confirm direction. The shed ahead offers shelter during rain and serves as a landmark visible from several gardens. Beyond it, a familiar roofline rises above the trees. each feature has carried more than one purpose during the journey. A fence can guide travel while separating neighbouring ranges. A hedge provides cover, holds scent, and creates a place to watch movement beneath the leaves. The garden may contain prey routes, warm resting surfaces, and passages used by several cats at different hours. The porch marks the final transition between the shifting outdoor landscape and the dependable resources inside. In southern Norway, the tracked cats spent an average of 79% of their outdoor time within 50 meters of home. That distance can be crossed by a person in less than a minute. For the cat, it can contain hours of movement and repeated decisions. Within that small radius, the animal may walk several kilometers by circling boundaries, retracing paths, and moving between useful locations. The area can hold the core of its range, parts of several neighboring ranges, and the routes of mice, birds, reptiles, or insects. A short distance can therefore contain a great deal of biological activity. The returning cat also carries several roles at once. It remains a companion drawn toward familiar people, warmth, food, and a secure place to rest. Its route home depends on remembered turns, recognizable surfaces, scent, sound, and other local cues gathered through experience. The same animal has moved through a social landscape shaped by marks left on posts, trees, and walls. It may have avoided a neighbor by changing direction or arriving at a shared garden several hours later. Hunting opportunities can appear during any part of that route. A rustle may activate orientation and stalking even when the cat has already eaten. Some pursuits end before contact. Others produce a capture that may be consumed outside, left beneath cover, or carried partway home. Human structures create risks alongside those opportunities. A road may cut across a known path. An open garage can become a temporary shelter and later a closed space. Outdoor water, unfamiliar animals, parasites, and contaminated soil add forms of exposure that may remain unseen when the cat returns. The path still has a recognizable structure. Most movement occurs within a home range rather than across the neighborhood without direction. A smaller core receives the greatest use. Fences, walls, sheds, vegetation, and quiet passages connect the most valuable places. Weather can shorten the route. Seasonal prey can draw it outward. Age, reproductive status, confidence, and local barriers help decide how far the animal travels. The home remains the strongest anchor because several predictable resources are concentrated there. Food arrives without a hunt. Shelter remains available during cold rain or intense heat. Familiar scents and social contact provide security. Rest can continue without watching for approaching animals or sudden disturbance. The outdoor landscape offers a different set of rewards. New scents appear along established paths. Movement in grass creates hunting opportunities. Raised surfaces provide views beyond the garden. The cat can choose among routes, resting places, and times of activity. Outdoor motivation draws the animal away from the house, while memory and dependable resources repeatedly guide it back. The cat reaches the porch and pauses near the door. Its coat may show no sign of how many boundaries were crossed or how many other animals use the same ground. A route covering only a few gardens has carried it through systems of geography, memory, communication, predation, risk, and disease. Human choices have shaped that route as well. Feeding schedules influence departure and return. Neutering can reduce reproductive travel. Curfews, supervised access, enclosures, and indoor enrichment can shorten the map or change when it is used. The cat steps inside and moves toward a familiar resting place. The outdoor range contracts once more into one animal beside a doorway. Beyond the walls, the roots remain. Scent traces continue fading on fence posts. Neighboring cats follow their own schedules through shared gardens. Prey moves beneath cover, and the same paths wait beneath the changing weather. The door closes on one journey, while the map outside remains ready for another.